So today we're going to talk a little bit about software developer productivity. And I wish that I always had the badge on that you see on the screen, hello, I am productive. But if you're like me, maybe not every day is quite like that. So this talk is really aimed at multiple kinds of audiences. You might be a software developer who wants to provide more value to your organization and get home earlier. You might be a manager who's interested in improving the output of your team. Or you might be a CIO striving to meet the needs of your organization for software. So I hope we have a little bit of something for everyone in the talk. You know, over the years, there's been so many attempts to try to measure software development productivity. We've looked at lines of code, we've looked at function points, we've looked at more sophisticated metrics. But despite all these efforts, a deep understanding of what makes a given developer or a given team productive is really not known and has really remained elusive. So in this talk, I want to tell you about some work I've been doing with colleagues at the University of Zürich, Microsoft Research, and UBC to gain some insight into software development productivity from really the bottom up. What do software developers perceive as enhancing and impeding their productivity? What do they actually do all day? And how can we help them streamline their work processes? So I'm going to start by looking a little bit about what we've learned by asking developers through a survey about how they perceive their own productivity. But we know that what people do is often different than what we think. So we moved from doing surveys to looking at observations that developers during periods they thought they were productive. And I want to tell you a little bit about those observations. And even with observations, we can't really capture everything that a developer does. So we've been doing some monitoring of their activity and doing some analysis of what they actually do if you look at it from keyboard strokes and mouse activities and applications they're using, what really seems to be happening. And then building on these results, we'll provide you a few ideas about ways that we might be able to help empower software developers and teams to improve their work and hopefully as a byproduct, really improve their productivity. So as Sarah said, if you have any questions, she'll feed them into me as we go, so happy to make this interactive. But let's start with perspectives about how developers think about their own productivity. This is really joint work with Thomas Fritz at the University of Zürich, his graduate student Andre Meyer, and Thomas Zimmermann at Microsoft Research. The fundamental question that we wanted to answer is when do developers actually perceive themselves as being productive, and when do they perceive themselves as being unproductive? To find out what we could learn from both of those viewpoints. The approach that we took was to survey a selection of software developers. We produced an online survey that had 28 questions. 8 of them were focused on developers' background and experience. 17 of the questions were about perceptions of their productivity and how productivity might be monitored. And 3 were on just inducements and disseminations of what we might do with the results. We recruited participants for the survey using both Twitter and within Microsoft itself. We received 379 responses, 185 from the general advertisements and 194 from Microsoft. So as you can see from the data on the screen, about 93% of the people responding considered themselves as developers, and they had a fair bit of experience on average. Because the responses were pretty balanced between the general population and specific to Microsoft, we analyzed the responses differently and didn't find much differences between the two populations. So I'll just present everything as an aggregate. Let's start with the conditions under which software developers thought that they were productive. We asked each participant to complete the sentence, I have a productive day when, in up to 3 different ways. The graphics on the screen show you the top 4 reasons mentioned by participants. Most participants said that their workday was productive when they completed tasks, achieved their planned goals, or made progress on their goals. The second most mentioned reason was actually being able to get into the flow. So maybe some of you, when you're working or when you're doing a sports activity, have gotten into that state of what we call flow, where we're really so focused on what we're doing that everything else fades into the background, and we're able to really feel like we make progress on a particular sport or a particular work item that we're trying to do. That really seems to happen to get into the flow when you have no or few interruptions or distractions. Approximately a fifth of all participants said that they had a productive day when they had no meetings, and approximately a fifth said that they felt they had a productive day when they at least had clear goals stated. Other questions that we asked the developers were in terms of more of the activities that they performed. The green graph shows the top 4 activities mentioned as productive, and not surprisingly, many developers cited coding-related activities as when they felt productive. You can also see that coding appears in the unproductive activity graph. Participants differentiated between productive coding, which was implementing a new feature, and unproductive ones, which tended to be more about debugging and testing. Many others had also mixed feelings about things like meetings. Some participants thought that meetings were clearly unproductive, as you can see in the large bar in the red graph, but 17% of the participants considered that meetings could be productive when they included clear decision-making, had a clear focus or goals, improved the relationships between developers, helped others, or when the meeting was well prepared. Unproductive meetings seemed to be ones in which goals were missed. There was no preparation. There are too many participants in the meeting, or the meeting goes over time. And I'm sure we've all had experiences like that. Participants were also really mixed on their views of activities like email. 18% considered email unproductive, whereas 10% actually considered the activity as productive. The amount of email appears to contribute to when it's seen as productive or unproductive. We had one participant who wrote in, tracking and responding to tons of emails and email communications going back and forth for days with no closure makes me feel really unproductive. In addition to understanding what leads to productivity, we also tried to find out a little bit from the developers about how they might actually measure their productivity. So this graph is a little hard to understand, but essentially what we were doing was for a whole bunch, 23 different possible measures, asking developers to rate on a 5-point Likert scale whether or not they really felt that the measure was good for considering their productivity or it was a bad measure. So the more green the bar is, the more they thought it was a good measure. The more orange or red the bar is, the more they thought the measure was not very useful. And we've ordered the graph from top to bottom in terms of the results that gave the most indication for people of productivity. So you can see right there up at the top is the number of work items. Closely followed behind is the time spent on work items. What was interesting to us was that the third highest rated measure was actually time on code reviews. You might have thought that people would think that participating in a code review, if it didn't lead to their own code, might not be so productive, but it felt, you can see the team aspects coming out, that they thought that code reviews were really useful. I've shown a few of the least useful measures at the bottom. Maybe not surprisingly, people didn't think the number of emails they wrote were really a measure of productivity. They also didn't think that the number of lines of code change or the number of code elements, like number of classes or number of methods, was a good indicator either. So from this kind of data, we can get some kinds of ideas of what people thought might actually be useful if we were to provide some sort of feedback about productivity.
Can I interrupt you for a question, a little clarification? On the previous slide, the number of work items, is that the number of work items finished or the number that are in process?
That was the number of work items finished.
Okay. Great, thank you.
Any other clarifications?
That was all.
Oh, okay. So a couple of takeaways from the survey that we conducted. You can certainly check out a publication that I'll link in at the end of the webinar if you want to read the full results. But here's kind of the high-level view. Even though we couldn't find a given single measure that all developers wanted to use to measure productivity, many of the participants did indicate that they would be interested in getting some feedback through various kinds of measures. When we asked the participants in a very open-ended question on what they actually want to measure to help meet their goals and improve their productivity, 27% of them mentioned measuring activities. They wanted to know also how much time they spend on their computer in terms of both meetings and taking breaks and coding. 18% of them were interested in the actual work that they performed and the progress that they actually made on the work. 17% wanted to measure the value of their work. such as the success of a feature or the value to a customer of the code that they had produced. And 16% of them wanted kind of overall measures, like the average time that they spent per task. So we really see this variety of perspectives on productivity as a pretty big opportunity. We know that humans are becoming more and more interested in doing tracking of their activity, given Apple Watches and Fitbits and various kinds of self-quantification that people are using, and that they can actually be motivated by and change their behavior if the right kind of data is provided. So there's some nice studies that show that the use of Fitbits can actually help improve health in particular parts of the population. We'd like to figure out what kinds of measures that developers might want feedback on so that we can make dashboards to really summarize the activities of an individual developer. These kind of personal dashboards might also help strike the right balance between gathering a lot of data, but making sure it's personal enough and kept private enough to the individual that they don't have to worry about Big Brother watching them. So as I said before, getting people's feedback about what they think is really useful, but we know that often if we ask people in a retrospective kind of way what they think, it doesn't always match what they actually do when you sit down and watch them at work. So the results of the survey really raised a lot more questions for us. Do developers have a common meaning for a task or a context switch, since those were very important to them? Are all interruptions that they complain about really necessary? So to enable us to investigate some of the results in more detail, we did an observational study. So the observational study really looked at three different kinds of aspects that came out of the survey. What is the role of tasks in a developer's work, and what kinds of tasks do they work on? What are context switches that they work with? And what kind of email are they working with? What kinds of things hinders people from being in the flow? The observational study that we conducted involved 11 professional software developers from 3 international software companies of varying size. So even though we had a very small sample set, we tried to vary the kinds of organizations that we were looking at, the kinds of development being done. 2 of the developers of the 11 were female, and the participants had on average about 5 years of experience. So for this study, what we did is we had a researcher sit behind each participant. They observed the work the participant was performing, and they coded the participant, in this case a developer's activities, for 4 hours. What we tried to do was to do 2 hours before and after lunch. The observer that was watching the participant logged every time that the participant switched a task. They logged what kinds of activities they were performing. They logged when they were interrupted. They logged when they were checking email, and so on. So the graphic you see on the screen gives a visual representation of the data that we collected. These bars that are running horizontally that are labeled R1, R2, T2, these represent a developer's work for 2 hours of the time that we observed them. Each bar is depicting a different person that we observed. The different letters that are encoding that y-axis are showing which companies that they were for. And the encodings, if you look on the legend, are showing you the different activity switches that happen. So anything that's kind of in that yellow to red circular is a different kind of development activity. We have various activities like email and planning that are downwards triangles of different colors. And you can see that the switches are happening a lot. So we jittered the little icons a bit so that you could see that many different switches are happening between all of these activities. If you look at the bars closely, you'll also see that there's different gray shadings. The different gray shadings indicate different task switches that are happening for the developer where they're at work. We observed the developers for 10 to 15 minutes, and then we stopped and showed them our logs so that we could make sure whether or not we were gathering the right kind of data. There's a lot that you can start to learn if you study this kind of graphic in detail. Perhaps the most striking aspect overall is simply the sheer number of activities that were worked on by participants and the really quick changes that were happening. So if you look at T1, which was the third from the bottom, you can see that this particular participant in 2 hours did 230 activity switches, these different kinds of development, planning, browsing activities. they had 79 task switches over 4 distinct tasks. Now, interestingly, when we asked the developers if they were actually productive during these periods, 8 out of the 11 said that they were fairly or very productive during the observational sessions. So let me give you kind of a little bit more insight into 3 of the themes that we've pulled out from this data. One is about the tasks that they worked on. So the participants worked on about 2 to 10 tasks in the periods that we looked at in the 4 hours observed, with a mean of just under 4 tasks each. The tasks included things like fixing a particular bug, reviewing code, helping coworkers with a problem, or reading or writing email. The task switches between the tasks happened really frequently, with a mean task switch rate of 13 times per hour. The task switches occurred for a lot of different reasons. It included helping coworkers make progress, unblock coworkers, self-interruptions for various reasons, and even simple things like waiting for a build to finish. By performing a task switch, participants mentioned that they could get small tasks done and help increase their overall productivity. The average time that they spent on any given task was 6.2 minutes before they switched to another one. And this frequent switching of tasks and total number of tasks is really similar that's reported to watching other kinds of information technology workers when they are working as well. We did note that the tasks we observed did not always equate to work items that might be documented and stored. If you remember, one of the highly rated measures by developers was to actually track the number of work items worked on and completed. However, we found that participants worked on many more tasks than trackable work items. So this difference might actually lead to a measure that underrepresents the many areas that a developer works on in any given hour and makes progress on. So you certainly won't want to rely on it as a sole measure of productivity. As indicated by all those little icons in the bars, the developers we observed switched activities really a lot. On average, the developers performed 47 activities per hour, with only 1.6 minutes on average spent before they switched to another activity. Sometimes those activities were in the same program, and sometimes they weren't. So we took a look at these bars and we analyzed them using an n-gram approach, which allows us to look at the most frequently changed between activities. Not surprisingly, testing often followed coding, and coding often followed testing. But coding was also often superseded by an informal meeting, either because somebody else asked them a question, or the participant had to go ask another developer a question to continue their own work. Emails were most often checked while coding or testing. The top 2 activities in which developers spent time were coding and informal meetings, which range from instant messages to also colleagues just interrupting them and asking a question. When they were performing these activities, developers used on average about 15 different programs, and several developers used multiple different programs to achieve similar activities. So we certainly took away that developers must be incredibly flexible and adapt to be able to move between all of these different activities and programs on which they were working. The final theme that I'll tell you a little bit more about the activities first. If we look at the number of activities and the amount of time that we were watching, you can see that coding really represents quite a large amount of the time that they spent, which might be good indication to their organizations that they really are on the task that people think that maybe they should be doing. Followed next by testing. Perhaps surprising to us was the fact that debugging was actually quite a bit lower than we might have expected. The other half of a developer's time is roughly spent on other activities, where things like informal meetings at 13% actually represent a reasonable chunk of any given developer's day.
Gail, can I interrupt you again for another question? So when you're counting the different applications, what about web-based apps? Do you count the different, say they were using a web-based version of Jira, or would that just be Chrome, for example, their browser?
Right. So in this particular study, because we're actually sitting there and watching, we can code the actual activity that was happening in the browser.
Okay.
So if they were working in Jira, that would have been counted as as perhaps planning if they were looking at a Kanban board.
Okay.
So we're able, if they're in the IDE, to know if they're debugging or testing.
Okay.
So that's one of the advantages of observations. Thanks for the question. Overall, we were surprised still by the number of task and activity switches that were going on. It certainly shows that developers have to be really, really quick, at least in the case of different companies that we were looking at. We were particularly surprised that 73% of those developers we observed thought they were being productive because of the number of context switches. When we asked them in the survey, context switches were one of those highest rated factors that led to a loss of productivity. So we were a little surprised to see so many going on when they said that they were being productive. So we asked them a lot about what a context switch was and how it actually relates to task and activity switches. The developers defined a context switch as when I have to stop thinking about one thing and start thinking about something else. So they explained that some context switches were really small, like getting distracted due to background noise, or switching between programs when working on the same task. Other context switches, they said, are really large, such as switching between a main task and a code review, or writing an email and switching between two very cognitively different tasks. Although all the participants agreed that context switches generally reduce their productivity, the cost or harm was really dependent upon the duration of the switch, the reason for the switch, and the focus on the current task. So in particular, the longer the switch, the more expensive it was. And we have a little quote on the screen from one of the participants. To stop and work on a different task is a more costly context switch than writing a quick email. So even if the quick email wasn't really related to what they were doing, they seemed to be able to cognitively really do that switch and go back to maybe the coding task they were working on more easily than if they were switching between two really intensive coding tasks. Similarly, the more focused the developer is on a task, the more expensive a switch is. Here's another quote. It depends on where I was. If it was a critical section, it's really hard to get back to focus on that task, even if it was for like 30 seconds. An example of a less expensive switch are ones that are usually self-inflicted, like going and getting a coffee or writing one of those quick emails that's unrelated to the current task. These distinctions in the kinds of context switches help explain why the developers felt productive despite the high number of task and activity switches we were observing. We saw how developers adapt to waiting times, such as waiting for builds to complete, by performing really low-cost switches to tasks on which they can make progress. We also saw how participants switched to simple tasks, such as 30 seconds of code review, without apparent significant impact to maybe the primary task on which they were working, like fixing a bug. So doing these observational studies really gives us kind of a different viewpoint on what a productive workday might look like for a developer. And there's a couple of things that we can really take away to maybe help developers avoid or prevent context switches, since it's those context switches that help them from being in the flow and being productive. The developers that we talked to and studied mentioned several strategies. They mentioned maybe closing your email, turning off notifications, listening to music, closing your office door, scheduling a meeting with yourself to protect your time in the company calendar, coming in early or working from home. One team used an explicit indicator. Here's a quote from them. All dev in our team have a physical light on top of our monitors that reflects our sync status, so people walking by can see whether or not to disturb. This has been really useful in reducing random interruptions. All of these strategies have to be balanced because even though they might improve an individual's productivity, you don't want the individual blocking other people on the team that leads to an overall loss of productivity for the team. So if we could do things like do a better job of automatically recognizing context switches, we might be able to help visualize that information to developers and help them really introspect and retrospect on their work patterns. That kind of automatic recognition can be challenging because it just doesn't depend on the program, like whether they're in JIRA. It also depends on the task they're working on and the semantics of the work being performed. But we have some ideas that we're working on now to try to really understand and develop these techniques that can do the automatic recognition. Now, I also said that observations have their drawbacks too. We're only able to observe, a limited number of developers for a short period of time. So we've been doing some more recent work on trying to see if we could understand what they're actually working on by installing monitors onto their computers so we can get really longitudinal data about how the developers work. So in this part, I'm only going to give you some very preliminary results, but we're interested in the question of, what do they really do all day when we can look at that from a really long period of time. So this monitoring study involved 20 participants where we were collecting from them not only data about their keyboard and their mouse activity and the applications that they were using, but we also popped up a little pop-up about every 2 hours that asked them what tasks they were working on, whether they had a productive period, and a few other simple questions to get some feedback but not interrupt their flow of work. We were actually logging their active process and window title at about every 10 seconds, as well as I said, all the mouse clicks, movements, scrolling, and keystrokes. So over the course of the study, we collected data from about 2,100 hours of work over 220 work days. So I'm going to give you a little bit of a sense of when we take all that very low-level activity and start to code it up into more themes and relate it back to some of the observational information we found. Going back to that question of what do developers actually do all day, this chart compares it to the observational studies. The percentage here of coding is a little bit lower at 21% than we saw in observations, which was 33%. So the red arrows on the side are showing you a little bit of comparison to the observational data. You can see we found very little indication of debugging time. Might be because we're not doing a good job yet of actually determining when debugging is happening from the data that we have. Coding still, though, does account for a lot of the developer's workday. If we compare to some of the other activities, we can see that email is still quite a bit of a developer's time, as is planning. Of course, trying to see those informal meetings is much harder from the activity data than if we're observing. So you can see that we have to find sort of some midpoint maybe between the observational data and the computer monitor data to really get a good idea of what was going on for these developers during their day. We also did these little pop-ups of asking developers every 60 to 90 minutes how they thought about their productivity, if it was good or bad in the previous period. And here's some representative charts from the
Sorry,
different
Gail.
people. Yeah.
Let me interrupt you just a second. On a couple slides back, VC was one of the activities listed. What does that mean?
That meant version control.
Version control. Thank you.
So if we take the productive levels that people reported over these different surveys, these charts are representative of 3 categories of individuals that we saw, and they might not be surprising to anyone. Essentially, each chart is showing the ratings of productivity that a developer gave over the entire time that we observed them at different times during the day. The person on the furthest left is kind of a morning person. Their highest ratings of productivity tended to be during the day, during the morning. We have people that were very low at lunchtime, so they were still working because they were reporting at noon, various activities that they were working on, but they were rating their productivity lower. And over on the right, we have one of the striking afternoon people, where their morning productivity ratings were always very low, but their afternoon ratings were very high. Overall, about 20% of the participants in our sample were morning people, so they were kind of the rarest form. Afternoon people were 40% of the people that we were monitoring. They may be ones that are very industrious later in the day, or maybe because the majority of their work was behind them at that point, they felt more productive. If we could provide people these kinds of reports as a dashboard, and they could recognize their own habitual patterns, it might be that that would be really helpful in guiding their own workday. I know I've started to think about it more by seeing these charts and thinking I should schedule some time in my calendar in the morning just for me, because that tends to be when I'm the most productive.
We had a.
So we're just starting right.
Sorry.
Yeah, do you have another question?
A question on that. Did you ask the participants what they considered themselves, if they considered themselves morning people, or if they had when their best productivity was?
You know, we didn't. In retrospect, we probably should have, but we didn't want to bias any of the data. But it would have been great to follow up later and say, does this actually represent who you are? There's some field work going on right now where we're doing more long-scale monitoring and more surveys. So hopefully in the next 6 months, we'll have some data that is able to kind of match whether or not people think it relates to how they actually perceive how they work.
Right. Cool.
Any other questions?
Let's see. We did have another question as well. She says, I'm a female developer, and I find I have different perceptions about work and productivity from my male counterparts. Female developers are underrepresented in the study. Do you have any insight on what differences there might be if more females were used?
Yeah, you know, unfortunately, until we get more data, that's going to be hard. And of course, getting more data is hard because we don't have as many females to sample to begin with. So
right.
I think we won't be able to say that much about gender bias or gender differences for any time in the foreseeable future, unfortunately. Interesting question, right up against International Women's Day. So
exactly.
I'll just have that question. So out of this study, you know, the data I've shown you is really just a glimpse of what we've done because we're still really analyzing that data. But it might be that from the data we've seen that development work is even more fragmented than when we were able to observe. Because we have some analysis that shows that the activities might be switching as often as in fractions of a second to 2 minutes per activity. We did find that there's some potential for having proxies of potentially indicating productivity because we have some, you know, very limited correlations between number of mouse clicks and keystrokes that might help indicate whether or not somebody is actually in the flow. And if you're in the flow, maybe you could do things automatically like turning notifications off for some period of time in a chat tool or in a Skype tool or something like that. The proxies might also help tell developers of when they're stuck and maybe when they should take a break. So there might be some opportunities to really have some tools that help people just introspect in the moment in a non-annoying kind of way so that overall they might be able to be more productive. But overall, maybe it's just learning what your habitual patterns are that can make the biggest difference. So out of all of this, you know, we know a little bit more about developer productivity. Are there ways that we could actually make things better? So I want to give you a few ideas about what we might do at the individual level, the team level, and the organization level. And I'm going to group the team and organization together in the interest of time. So at the individual level, our research shows really some very simple ways, and I'm saying simple kind of facetiously, given how hard we know it is to change people's behavior, some simple ways to maybe improve your own productivity. One is we heard time and time again how important setting goals is. The simple act of writing down what you're intending to do and tracking your progress on those goals can really help focus what you're doing at the moment and can help you determine if you're making progress. And remember, one of the highest rated reasons of why people felt they were productive is when they were completing tasks or making progress on goals. A second thing you might do is actually organize your workday to minimize interruptions. Think about whether or not you're a morning person or an afternoon person. Maybe you could organize your work to enable that uninterrupted flow time, even if it means closing your email or scheduling meetings with yourselves in those time periods that you feel most productive. We really found that when people could align those time periods to be when they could have those non-interrupted flow times, really helped them make them feel that they were more productive. And really achieving that flow state, you've just got to manage those distractions. So what is it you can do in your work environment? Is it putting on headphones? Is it working in a different place? Is it turning off all of those notifications and Slack channels and everything else that we have going? But some way to really minimize that can make a really a effective workday potentially for you. So I did mention earlier that focusing only on the individual can really harm the team. For instance, the number of interruptions that occur because colleagues are asking for information, if you prevented all those interruptions, you're going to really hurt the team as a whole. So what can we really do to improve productivity for a team or an organization? Well, both the survey and the observations we conducted showed us really different views on meetings. Some people thought meetings were extremely productive. Some people thought that they really hindered their productivity. And a lot of those differences depended on how the meetings were held and how they were conducted. Meetings with specific agenda, appropriate people in the room, and clear decisions were viewed productively. Meetings without those characteristics were not. So given that meetings often constituted a fairly significant portion of a developer's time, it could be that in your organization, just making people think about meeting practices, maybe some training on good meeting practices, could yield significant benefits for fairly low cost. If we have better tool chains that support context and flow, we also might be able to improve productivities of teams and organizations. And certainly from our customers at Tasktop, we've heard themes like that as well. Because Tasktop really has spent the last 9 years trying to develop tools in this area. So let me tell you about how those tools can really help address context and flow, and how they can help do some streamlining of communications just very, very briefly. Our Tasktop Dev tool, often makes you think of programmers working alone. With my kids, I watched Jurassic Park again recently, and the programmer is that guy who's just alone on his keyboard and working solely and independently. But we all know that that's not the way that software development really occurs today. So fundamentally, kind of keeping that flow within a team is really knowing what those different members of your team are working on. Tasktop Dev really helps you do that by bringing information about your team through things like your issue tracker directly into the development environment. We're really trying to minimize at least those huge program switches that might be hindering your productivity. When a teammate comments on a shared issue that you might have, you see that information right away in the context of that entire issue. So you're not flipping back and forth between email and trying to keep threads of email going together. Dev also helps you build, with its built-in multitasking, maybe do those context switches a little bit more fluidly, so you're not spending as much time trying to build up the context of all the software that you're working on for a given task. And given that huge number of tasks that we saw people were switching between, trying to minimize both the switches that happen and the friction of making a switch can make a significant difference. And finally, Dev has some capabilities to be able to track what a developer does and allow you to retrospect about where you're spending your time. And I think we've seen, as I said, with the self-quantification approach, that might actually start making a significant difference in how developers spend their time and think about spending their time. While Tasktop Dev can help address a developer's workflow, Tasktop Sync is really more about the development team. Each role in a team is often served best by a particular tool, might even vary within an organization per team. For instance, it wouldn't make much sense to have your business analysts working in an IDE because they probably require features best found in a tool that's about defining and tracking requirements. Similarly, you wouldn't want your testing staff that wasn't in a tool meant to support QA activities. The Tasktop Sync product really enables the individuals on your development team to use the best-of-breed tools for their activities, whether it's requirements, testing, portfolio management, whatever it is, whatever kind of tool that they need. Tasktop Sync will allow the information within their tools to be transmitted and integrated with communications between the teams so that when the business analyst updates information about the requirement, that can flow to the tester automatically in their tool so they have the most up-to-date information about testing a requirement. Similarly, the information from the tester can flow to the developer, can flow up to the project manager who needs to know what the status is of any given point in the development. So by keeping development staff in their own tools and focused on their work, we can help reduce the interruptions that need to happen just to go gain information. Because sync is going to make sure that the information is in the right place for each member of the team. So we've had a fair bit of success in having Tasktop Sync be used by Fortune 100 companies to really scale their agile development and help move them to DevOps. Where Sync gives you that ability to allow members of your team to have that strong communication and information flow, Tasktop Data, our newest product, really lets you think as an organization about your software development processes. All of that information that Tasktop Sync is routing between tools can be surfaced using Tasktop Data, so you can start to ask and answer questions that really span the software development processes you use. For instance, you might be interested in which teams are producing the most severe defects and in which conditions those defects are happening. You might need to know how quickly defects are being fixed by different teams, or what kinds of features are resulting in the most common kinds of complaints. And I'm sure for your organization, you can imagine many, many different kinds of questions. Tasktop Data can help you answer those kinds of questions and really start to investigate the traceability in your development processes. So what would I like you to really take away from this talk? Well, there's really these four kinds of things. Improved productivity within an organization can really start with the individual. Improved productivity doesn't mean you have to change everything. If you think about how your developers are spending their time and analyze it, you can start thinking about ways to improve software development productivity minute by minute. By gaining insights into how developers think about their productivity, for instance, we learned that individualized measurements of productivity and retrospection might be useful. By gaining insights into how developers actually work, we learned about some habitual work patterns that might be improved both through simple mechanisms and places where maybe we have to do some more research to really help people. And I gave you some ideas about how you might improve software development productivity today and the kinds of tools that might be used to improve flow, reduce fragmented work for both individuals and teams. If you want any more information on the subject of this talk, you'll find if you look up the slides later that there's some contact information, and publications that we have to provide all the details. I'd like to say that, Tasktop has supported this work as well as government funding agencies like NSERC and ABB, and has really benefited from all the developers that have allowed us to watch them, allowed us to monitor them, and have taken the time to answer our surveys. So thanks a lot for joining me. I'd be happy to answer any questions that you might still have.
Great, thank you, Gail. We have a few questions and also a lot of comments. A lot of people are saying this, this sounds a lot like my life, all the context switching. We did get one person asking you to clarify how exactly you define context and flow.
Yeah, I wish I could give you, sort of precise mathematical definitions of context and flow. We're certainly not there, and I don't think we ever will be. For us, a context switch is really self-defined at this point by a developer. Obviously, task and activity switches are easier to define. The context switches are really about when there's a major change in what a developer is doing. So they felt that context switches are when they had to make kind of a whole-scale cognitive change to something else, which may not just be a task switch, which might be fairly easy, but when they had to move maybe from one feature to another feature that required them to think about something very, very different. I think you had another question. It was context switches, and what was the second part of the question?
That is all I see on that. Oh, yeah, it was just defining context switches and flow, sorry.
Flow, okay. Right, so the idea of flow is really, I don't think you can give an outside definition of it. Psychologists have investigated flow for a very long time. And for those of you who know flow, it was invented by a Russian named psychologist who did most of his work in the US. With such a long name, I'm not even going to try to pronounce it. But there's a number of properties that people believe are true of flow. So it's more that you can recognize a flow state rather than precisely define when a flow state happens. And the characteristics will vary individual by individual. The major way that we use flow is when developers are able to make very, very clear progress on a defined goal with a minimum of interruptions and where they're able to block out other work because they're so focused on what they're doing. Hopefully that helps a little bit.
Yeah, thank you. We had another question about how you used, what software you used during the monitoring study. Just a little bit more information on that.
Yeah, so the software we used on the monitoring study we built, and so it was, at that time it was only Windows-based. We now have Mac-based monitoring, but do not yet have Linux-based monitoring, so that biases our information a bit too. It basically looks in the event loop to be able to get out all of those key activities that are happening, the mouse clicks, getting into the right parts of the operating system to be able to sample what windows are active and taking the titles of the window so that in most cases when they're in the browser we know if they're in, for instance, Jira, or if they're on some random news page, or if they're on Facebook or something else. So grown at home monitoring software.
Great. And there's kind of a second part to that question. They wondered if you felt that one method was kind of more accurate than the other, if the monitoring, if someone looking over your shoulder perhaps was impacted how you actually worked.
So what's really been interesting over the many observational studies we've done is I think that there's some impact in the first 10 to 15 minutes where somebody's watching, and then often the developer at work completely forgets that there's somebody behind them. So I think that it doesn't bias it too much. We can certainly get much better at this point in time task switching information than we could if we're just trying to infer that from very detailed monitored information. But our end goal would be that our monitoring information gets to be close to the efficacy of our observational data, because then we just get that much more longitudinal information and we can eliminate a lot of that bias that might be introduced by somebody sitting and watching over your shoulder. So I'm not sure that one is really, we really need both right now to kind of triangulate the signals that are coming out. I think over time we will be able to build up the monitoring to do a much, much better job of trying to both understand what programs and activities are happening at the low level, but also the task switches. So we're doing some research now to see if from the content of what's happening on the screen, if we can see when task switches are actually occurring. So I'm pretty excited to see the results of that.
Great. Well, I think that is all we have. Those are all the questions that we have, and we're running pretty short on time as well. So I wanted to thank everyone for joining. And again, as Gail said, you can find more information about Tasktop and our products on our website, www.tasktop.com. And we will be sending you the recording and some more information after the webinar. So,
and if you have more comments, reach out. Happy to have that too.
Great. Well, thank you, everyone. And thank you, Gail. And this concludes our webinar.